The Boeing B-52 Stratofortress is an American long-range, subsonic jet-powered strategic bomber. The B-52 was designed and built by Boeing, which has continued to provide support and upgrades. It has been operated by the United States Air Force since the 1950s. The bomber is capable of carrying up to 70,000 pounds or 32,000 kilograms of weapons, and has a typical combat range of more than 8,800 miles or 14,080 kilometers without aerial refueling. Beginning with the successful contract bid in June 1946, the B-52 design evolved from a straight-wing aircraft powered by 6 turboprop engines, to the final prototype B-52, with 8 turbojet engines and swept wings. The B-52 took its maiden flight in April 1952. Built to carry nuclear weapons for Cold War era deterrence missions, the B-52 Stratofortress replaced the Convair B-36 Peacemaker. A veteran of several wars, the B-52 has dropped only conventional munitions in combat. The B-52's official name Stratofortress is rarely used. Informally, the aircraft has become commonly referred to as the BUF. The B-52 has been in service with the USAF since 1955. As of June 2019, there are 76 aircraft in inventory, 58 operated by active forces, 2nd Bomb Wing and 5th Bomb Wing, 18 by reserve forces, 307th Bomb Wing, and about 12 in long-term storage at the Davis-Montana AFB Boneyard. The bombers flew under the Strategic Air Command, SAC, until it was disestablished in 1992, and its aircraft absorbed into the Air Combat Command, ACC. In 2010, all B-52 Stratofortresses were transferred from the ACC to the new Air Force Global Strike Command, AFGSC. Superior performance at high subsonic speeds and relatively low operating costs have kept them in service, despite the advent of later, more advanced strategic bombers, including the Mach 2 plus B-58 Hustler, the cancelled Mach 3 B-70 Valkyrie, the variable geometry B-1 Lancer, and the stealth B-2 Spirit. The B-52 completed 60 years of continuous service with its original operator in 2015. After being upgraded between 2013 and 2015, the last airplanes are expected to serve into the 2050s. On 23 November 1945, Air Material Command, AMC, issued desired performance characteristics for a new strategic bomber, capable of carrying out the strategic mission without dependence upon advanced and intermediate bases controlled by other countries. The aircraft was to have a crew of 5 or more turret gunners, and a 6-man relief crew. It was required to cruise at 300 miles per hour or 480 kilometers per hour, at 34,000 feet or 10,400 meters, with a combat radius of 5,000 miles or 8,000 kilometers. The armament was to consist of an unspecified number of 20mm cannon and 10,000 pounds or 4,500 kilograms of bombs. On 13 February 1946, the USAF issued bid invitations for these specifications, with Boeing, Consolidated Aircraft, and Glenn L. Martin Company submitting proposals. On 5 June 1946, Boeing's Model 462, a straight-wing aircraft powered by 6 Wright T-35 turboprops with a gross weight of 360,000 pounds or 160,000 kilograms, and a combat radius of 3,110 miles or 5,010 kilometers, was declared the winner. On 28 June 1946, Boeing was issued a letter of contract for US $1.7 million to build a full-scale mock-up of the new B-52 and do preliminary engineering and testing. However, by October 1946, the USAF began to express concern about the sheer size of the new aircraft and its inability to meet the specified design requirements. In response, Boeing produced the Model 464, a smaller 4-engine version with a 230,000 pound or 105,000 kilograms gross weight, which was briefly deemed acceptable. Subsequently, in November 1946, the Deputy Chief of Air Staff for Research and Development, General Curtis LeMay, expressed a desire for a cruising speed of 400 miles per hour or 645 kilometers per hour, to which Boeing responded with a 300,000 pounds or 136,000 kilograms aircraft. In December 1946, Boeing was asked to change their design to a 4-engine bomber with a top speed of 400 miles per hour, range of 12,000 miles or 19,300 kilometers, and the ability to carry a nuclear weapon. In total, the aircraft could weigh up to 480,000 pounds or 220,000 kilograms. Boeing responded with 2 models powered by T-35 turboprops. The Model 464-16 was a nuclear-only bomber with a 10,000 pound or 4,500 kilograms payload, while the Model 464-17 was a general-purpose bomber with a 9,000 pound or 4,000 kilograms payload. Due to the cost associated with purchasing 2 specialized aircraft, the USAF selected Model 464-17 with the understanding that it could be adapted for nuclear strikes. In June 1947, the military requirements were updated, and the Model 464-17 met all of them except for the range. It was becoming obvious to the USAF that, even with the updated performance, the XB-52 would be obsolete by the time it entered production, and would offer little improvement over the Convair B-36 Peacemaker. As a result, the entire project was postponed for 6 months. During this time, Boeing continued to perfect the design, which resulted in the Model 464-29, with a top speed of 455 miles per hour or 730 kilometers per hour, and a 5,000-mile range. In September 1947, the Heavy Bombardment Committee was convened to ascertain performance requirements for a nuclear bomber. Formalized on 8 December 1947, these requirements called for a top speed of 500 miles per hour or 800 kilometers per hour, and an 8,000-mile or 13,000 kilometers range, far beyond the capabilities of the 464-29. The outright cancellation of the Boeing contract on 11 December 1947 was staved off by a plea from its president William McPherson Allen to the Secretary of the Air Force Stuart Simonton. Allen reasoned that the design was capable of being adapted to new aviation technology and more stringent requirements. In January 1948, Boeing was instructed to thoroughly explore recent technological innovations, including aerial refueling and the flying wing. Noting stability and control problems Northrop was experiencing with their ib-35 and ib-49 flying wing bombers, Boeing insisted on a conventional aircraft, and in April 1948, presented a US $30 million proposal for design, construction, and testing of 2 Model 464-35 prototypes. Further revisions during 1948 resulted in an aircraft with a top speed of 513 miles per hour or 825 kilometers per hour, at 35,000 feet or 10,700 meters, a range of 6,909 miles or 11,125 kilometers, and a 280,000 pounds or 125,000 kilograms gross weight, which included 10,000 pounds or 4,500 kilograms of bombs, and 19,875 US gallons or 75,225 liters of fuel. In May 1948, as design effort was underway, AMC asked Boeing to incorporate the previously discarded jet engine, with improvements in fuel efficiency, into the design. That resulted in the development of yet another revision in July 1948. Model 464-40 substituted Westinghouse J-40 turbojets for the turboprops. The USAF project officer who reviewed the Model 464-40 was favorably impressed, especially since he had already been thinking along similar lines. Nevertheless, the government was concerned about the high fuel consumption rate of the jet engines of the day, and directed that Boeing still use the turboprop-powered Model 464-35 as the basis for the XB-52. Although he agreed that turbojet propulsion was the future, General Howard A. Craig, Deputy Chief of Staff for Material, was not very enthusiastic about a jet-powered B-52, since he felt that the jet engine had not yet progressed sufficiently to permit skipping an intermediate turboprop stage. However, Boeing was encouraged to continue turbojet studies, even without any expected commitment to jet propulsion. B-52 was born. Boeing was awarded a production contract for 13 B-52s and 17 detachable reconnaissance pods on 14 February 1951. The last major design change, also at General LeMay's insistence, was a switch from the B-47 style tandem seating to a more conventional side-by-side cockpit, which increased the effectiveness of the cockpit and reduced crew fatigue. Both XB-52 prototypes featured the original tandem seating arrangement with a framed bubble-type canopy. The proposed variant of the B-52H was the AB-52H, which would have consisted of 16 modified and augmented B-52H airframes, with additional electronic jamming capabilities. This variant would have restored USAF airborne jamming capability that it lost on retiring the F-111 Raven. The program was cancelled in 2005, following the removal of funds for the standoff jamming. The program was revived in 2007, and cut again in early 2009. In July 2013, the USAF began a fleet-wide technological upgrade of its B-52 bombers called Combat Network Communications Technology, CONNECT, to modernize electronics, communications technology, computing, and avionics on the flight deck. CONNECT upgrades include software and hardware such as new computer servers, modems, radios, data links, receivers, and digital workstations for the crew. One update is the NR-210 Warrior Beyond line-of-sight software programmable radio, able to transmit voice, data, and information in flight between B-52s and ground command and control centers, allowing the transmission and reception of data with updated intelligence, mapping, and targeting information. Previous in-flight target changes required copying down coordinates. The R-210 allows machine-to-machine transfer of data, useful on long-endurance missions where targets may have moved before the arrival of the B-52. The aircraft will be able to receive information through Link 16. CONNECT upgrades will cost $1.1 billion overall and take several years. Funding has been secured for 30 B-52s. The USAF hopes for 10 Connect upgrades per year, but the rate has yet to be decided. The B-52 shared many technological similarities with the preceding B-47 Stratofortress strategic bomber. The two aircraft used the same basic design, such as swept wings and podded jet engines, and the cabin included the crew ejection systems. On the B-52D, the pilots and electronic countermeasures (ECM) operator ejected upwards, while the lower deck crew ejected downwards. Until the B-52G, the gunner had to jettison the tail gun to bail out. The tail gunner in early model B-52s was located in the traditional location in the tail of the plane, with both visual and radar gun laying systems. In later models, the gunner was moved to the front of the fuselage, with gun laying carried out by radar alone, much like the B-58 Hustler's tail gun system. In September 2006, the B-52 became one of the first U.S. military aircraft to fly using alternative fuel. It took off from Edwards Air Force Base with a 50-50 blend of Fischer-Tropsch process, FT, synthetic fuel and conventional JP-8 jet fuel, which burned in 2 of the 8 engines. On 15 December 2006, a B-52 took off from Edwards with the synthetic fuel powering all 8 engines, the first time a USAF aircraft was entirely powered by the blend. The 7-hour flight was considered a success. This program is part of the Department of Defense's Assured Fuel Initiative, which aimed to reduce crude oil usage and obtain half of its aviation fuel from alternative sources by 2016. On 8 August 2007, Air Force Secretary Michael Wing certified the B-52H as fully approved to use the FT blend. Because of the B-52's mission parameters, only modest maneuvers would be required with no need for spin recovery. The aircraft has a relatively small, narrow chord rudder, giving it limited yaw control authority. Originally, an all-moving vertical stabilizer was to be used, but was abandoned because of doubts about hydraulic actuator reliability. Because the aircraft has 8 engines, asymmetrical thrust due to the loss of an engine in flight would be minimal and correctable with a narrow rudder. To assist with crosswind takeoffs and landings, the main landing gear can be pivoted 20 degrees to either side from neutral. This yaw-adjustable crosswind landing gear would be preset by the crew, according to wind observations made on the ground. The elevator is also very narrow and chord like the rudder, and the B-52 suffers from limited elevator control authority. For long-term pitch trim and airspeed changes, the aircraft uses an all-moving tail with the elevator used for small adjustments within a stabilizer setting. The stabilizer is adjustable through 13 degrees of movement, 9 up, 4 down, and is crucial to operations during takeoff and landing, due to large pitch changes induced by flap application. In 2007, the Lightning targeting pod was fitted, which increased the effectiveness of the aircraft in the attack of ground targets, with a variety of standoff weapons, using laser guidance, a high-resolution forward-looking infrared sensor, FLIR, and a CCD camera used to obtain target imagery. Lightning pods have been fitted to a wide variety of other U.S. aircraft, such as the McDonnell Douglas FA-18 Hornet, the General Dynamics F-16 Fighting Falcon, and the McDonnell Douglas AV-8B Harrier II. The ability to carry up to 20 AIM-69 SRAM nuclear missiles was added to G and H models, starting in 1971. To further improve its offensive ability, air-launched cruise missiles, ALCMs, were fitted. After testing of both the USAF-backed Boeing AIM-86 and the Navy-backed General Dynamics AIM-109 Tomahawk, the AIM-86B was selected for operation by the B-52, and ultimately by the B-1 Lancer. A total of 194 B-52GS and HS were modified to carry AIM-86s, carrying 12 missiles on underwing pylons, with 82 B-52HS further modified to carry another 8 missiles on a rotary launcher fitted into bomb bay. To conform with SALT II treaty requirements that cruise missile-capable aircraft be readily identifiable by reconnaissance satellites, the cruise missile-armed B-52GS were modified with a distinctive wing root fairing. As all B-52HS were assumed modified, no visual modification of these aircraft was required. In 1990, the stealthy AIM-129 ACM cruise missile entered service. Although intended to replace the AIM-86, a high cost in the Cold War's end led to only 450 being produced. Unlike the AIM-86, no conventional, non-nuclear version was built. The B-52 was to have been modified to utilize Northrop Grumman's AIM-137 TSS AM weapon. However, the missile was cancelled due to development costs.